Hi everyone, this is Steve Smith at the SPARQ Observatory, and we are continuing our photometry projects. We're going to use a spreadsheet in Excel called AIJexcel that's going to analyze the photometry measurements that we did in AIJ. At this point, we've completed all the other steps, so we're on the last step now. The first thing that we did, of course, was acquire the image. So we used the SPARQ Observatory equipment to acquire images of our target as well as take calibration frames. We used PixInsight's Blink tool to quickly go through all the images and look for things like clouds overhead or satellites through our target star or comparison stars. And using that tool, we were able to select just the best images and reject the bad ones. We then went over to AIJ or Astro Image J to do the image calibration. This included applying bias frames, which takes out the readout noise of the chip. We also did dark frames, applied dark frames to our raw images, which takes out the thermal noise from the chip. And then we also applied flat frames, which takes out little dust bunnies and maybe some scratches or imperfections on any of the glass surfaces in our equipment. And then finally, we went over to, stayed in AIJ and did the photometry. So we used our AAVSO star chart and photometry table to input the magnitudes for the comparison stars into AIJ, and AIJ performed the photometry. And what we end up with there is a measurement table, one for each filter. So if you use the B filter, you have a B filter measurement table as well as a V. Everyone should have a V measurement table as well if you're just doing a time series. So that's where we've gotten to at this point, and the last step is in this video, which is the photometry analysis, and we use a program called AIJexcel. AIJexcel has a number of functions in it. Obviously, the first thing it has to do is it has to download the AIJ measurement tables, so it does that. Creates light curves, both in magnitude and for temperature if you've used the B filter. The light curves can also be specified for individual sessions and or for the individual filters. So let's say that you did 3 sessions. You can select to look at the light curve for just session 3, and maybe you just want to look at the V filter for that. This program can do that as well. For the comp stars, it does a number of comparisons. What it's really interested in, what we're really interested in, is looking at the standard deviation of the photon flux in the individual comp stars, as well as comparing every comp star to every other comp star. What we're looking at is to see if there's something outside of the normal standard deviation that makes us think that we shouldn't include an image in our analysis. So it will do that for you. For every type of analysis that you do, it will generate a summary for you. So it will generate a summary for all the light curves at once with all the filters. Each time you decide that you just want to look at one session or one filter, it will generate a new summary just for that session or filter. It also has the ability to create an AAVSO report. So this would be a file that you can upload to AAVSO. It knows what the AAVSO formatting requirements are and takes the data that you have and writes the report for you. And it also creates periodogram data, which is essentially a very simple 2-column data sheet that has the Julian date and also the photon flux for your target. And that can be uploaded to a periodogram site. We use the NASA exoplanet site periodogram tool. And that will give you a strength rating for the different cycles that it finds. And you can see if your star has a regular cycle or, even more interestingly, if it doesn't. So here we are with the AIJexcel spreadsheet. For those of you not familiar with Excel, spreadsheet allows especially a lot of mathematical functions to happen with your data. It's set up, we have this workbook set up to have a number of sheets in it. The sheets are listed as tabs at the bottom. So right now we're on the magnitude sheet. It says that down here at the bottom, and then also in the upper left-hand corner. We also have a temperature sheet. We have the comparison stars sheet, which is here, where the AAVSO report can be written to on this sheet. Same thing with a periodogram. It's got its own sheet. Then these other sheets, AIJ, this is where the data from the AIJ measurement tables are downloaded to. It doesn't pull everything off. It just pulls off the things that we need. And it does include all the sessions from all the filters. So with AIJ, the measurements table do not include the filters. So we have to save those measurement tables with the filter in the name of the file. And then when we upload it, download it, the AIJ measurements table to this program, it reads that and puts in the name of the filter on this sheet for each image that was taken. Results data, we don't need to worry about this. That's just a place where different data gets copied, so it's easier to recall rather than having to reanalyze a lot of things. Star and file data, we will need to use this. If you remember when we did the AIJ photometry, there was a point where AIJ prompted you for the magnitude of the comparison stars. This program will do the same thing. So you'll need to have your AAVSO photometry table in front of you. The addition that we have in this that we didn't have in AIJ is this program will also ask you for the uncertainty, which is included with the AAVSO measurements. And we didn't need that with AIJ, but we do need that for this program. The next sheet is called JD conversion, and this just converts the Julian date to our local date and time. And it does that automatically depending on what types of points or data points it finds interesting. And then the last sheet on here is settings. And we don't need to worry about this either. The defaults are fine, but I'm not going to go into any details on how all this works. But if you want to play around with it or explore with different ways to use the settings, you're certainly welcome to do that. So the other thing that you're going to have to do is you're going to have to know what the blue, if you're using blue, you're going to have to know what that value is. And so we did that before, and on your AAVSO sheet, you have a magnitude for V, and you have a magnitude for B minus V. And what we have to do is we have to add those two together to get the actual V value. And so we need to do that for each of our comparison stars. So we need to have that photometry table open in front of you. We'll also need the sequence chart, which is written on the photometry table as report this sequence as blah, 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 in the chart field of your observation report. And we'll need to have the star names, the AAU ID, the Astronomical Union ID for each of the stars. So we're going to do that now. We're going to go to the magnitude sheet. This is where most everything happens. Anytime you see a dark green background with this white text, if you double click on the text itself, it will run the program associated with the text there. So we're going to start with download and analyze. I'm going to double click on that, and I'm going to navigate to our ANLIN folder. And we want to select the folder, not the individual files. And you'll notice you can't select the individual files. They're grayed out. We want the folder that has everything in it. If I go down here to this star, FKCOM, it has only one file in it for V, but we would again just select the folder, not the file. So we want to select the file. We're going to go down to the bottom right and click Choose. And the first thing it's going to do is upload the files, and then it's going to ask you to confirm that this is the target. So it appears that the target is ANLIN. That's correct. And now it's going to start to ask for the different comp star measurements. So the chart ID is first, and that's going to be X39939BHM. We're going to input that. By the way, this is used if we want to create an AAVSO report. We need to have the chart ID in there. That's why that's there. So we're going to click that. The ID for the comp star 1. So this is the AU ID in the first column on your photometry sequence table. And for this star, that's going to be BML-908. And I'm going to, OK. And then we're going to enter the V magnitude, followed by the space or semicolon, and then its uncertainty. So the magnitude that AAVSO has for this star is 10.973. And I'm going to put in a semicolon, and then the uncertainty is 0.031. It's then going to ask for the B value. So this is where we added the V to the B minus V value. And the B value, B magnitude here, is 11.72. And the uncertainty is 0.08. I should say that we actually use the uncertainty measurement that is listed under the B minus V column. We don't have to calculate a different uncertainty, even though we're having to calculate the actual B magnitude. All right, so we do that. What is the ID for comp star number 2? So you would just continue this through as many comp stars as you have, and when you're done, eventually you get to a prompt where it says, what is the ID for the comp star, whatever, 7 or whatever, and you just click OK and leave it blank, and it will continue. So I'm not going to take up your time or my time right now to put in all these stars on this video, so I'm going to leave it here, and then I'll come back when I have all the stars inputted. So I have now inputted everything, and I've stopped the program. Normally the program would just continue on and do all the analysis, but I wanted to stop it here and kind of show you on the star and data file sheet what ends up happening. So there are 2 sections. The first section is this very long star data. So this is for all the targets and all the comparison stars that we've done at the SPARQ Observatory. And then over on the, a little further on the right, are the chart IDs with the target and the comp star IDs. So the last one that I did, we did AN Lin, which is here, the third one down. There's the chart ID that we inputted. And then we have the 4 AU ID for the 4 comparison stars, all BML 908, 910, 911, 912. All right, so those are the names of the stars in the chart. If we come down here back to our star data and we scroll down, we'll see that we have these comparison stars listed down here. These are the 4 BML stars over here. And then we come way over here to the right, and these columns are for different filters. So this is the B filter with its uncertainty that we inputted, as well as the V and the V uncertainty for the first comparison stars, and then we have the next 3 comparison stars. So we had 4 comparison stars. We had B values and uncertainties for those, and we have the V values and the uncertainties for those. So that's where this data goes. Once it's here, it's here. You don't have to upload it again. Type in the different the chart ID and the astronomical union ID. Once it's here, and we don't have to do that if we come back and have to download the data again. All right, so I'm going to go back here and go ahead and double click download and analyze again. By now, if you've done this, you get to your last comparison star, inputting your last comparison star. It will run the analysis from there without you having to do what I'm doing. So I'm just going to go to download analysis. I'm going to select the AN Lin folder again. It will ask for a confirmation that this is the target, but now I won't get any prompts for any of the comparison stars because we already have everything in there. And it has completed the analysis. This is the measurements, the magnitude sheet, and we've got a bunch of dots. Some are in green, some are in blue. The green indicates the V filter, B indicates the blue filter. If we come over here to the temperature sheet real quick, you'll see that we have everything in black, and what it does is, in order to get the temperature, it compares the V magnitudes that we get with the B magnitudes that we get, and that's how we end up with this. Now this looks a little messy. We've got dots and we've got some numbers on here. We can spread this out, and one of the ways we can deal with this a little bit better is we can just go ahead and look at one session, or we can rotate through all of them. So I'm going to click on recall individual session, and let's just look at the first session. And it says realize there are 3 different sessions, and we can see this by we have 3 different groups here. So these are the 3 different sessions. And default is session 1, that's fine, we'll go there. And it has recalled and charted our first session. So this is the first session that we got. The chart has the name of the star, that our target star A and Lin, telling you that this chart is for the magnitude, and this is session 1. Gives you the JD date for the session 1 and the local time and date. So these were imaged on January 14th from a little after 9 o'clock to the morning of January 15th at about 6:30 in the morning. Each of these dots represents one image, the analysis from one image. And again, this is magnitude. In the chart, going on the x-axis, we have the Julian date values. And on the y-axis, we have magnitude with lower magnitude or brighter at the top and higher magnitude or dimmer at the bottom. And we can see that we've got a nice shape to this star. This is a Delta Scuti star, by the way. So in one session, it can go through a bunch of different cycles. Over here to the left of the chart, we have our summary. So it's telling you that this is summary session 1. It's giving you the start and end JD times and how much total time was involved. So 0.39, so about 0.4 times 24, that would give you the number of hours that it was imaged, and the local date and time, and local time, and it looks like about 9.5 hours of imaging that evening. I'm going to scroll down here just a bit to see the rest of the summary. Didn't need to go that far. Come back up a little bit. Number of sessions. This is just one session. It found 194 original data points. So 194, we go to the AIJ sheet. Each one of these rows is a single image, the data from a single image. So in this first session, it found 194 data points, and it used all 194. So what that means is in this first session, it didn't find any outliers. So it analyzed the standard deviation for the individual comp stars and then compared the standard deviation of each comp star to the other comp stars as an ensemble, looking for any anomalies, any outliers. It didn't find any. The images are binned at 1. So what that means, when we talk about when we're imaging, we use 1 by 1, 2 by 2, 3 by 3. That has to do with how the chip reads out the data. This is something different. This is grouping. If we want to group images as maybe like 3 images at a time, we can do that with this program. Right now on the initial analysis, we have in our settings way over here, this sheet here, we have our bin image data set at 1. We can change that to whatever number we want, and it will group images together and take an average reading of what those groups are for each. So if you did 3 images together, it would average the Julian date, the magnitude, the error mass, etc. It would average all those out, the total number divided by however many images you were binning at. We've got 96, if we continue on, V is in green here, 96 V points, average magnitude 10.63. The main fluctuation was between 10.55 and 10.72, which gives us a magnitude change of 0.17, and the average error is about 0.002. And we have the same information for the B filter. The V filter average magnitude was 10.63, B 10.8, which is about what we would expect. Underneath this is all the data that it used for this summary. So when we image at SPARQ, if we're using 2 different filters, we set it up to start with the V filter and do 3 at a time. So it'll do 3 V's and then move on to 3 B's. This is arranged chronologically according to Julian date. So we've got for each image, it will put the data in either the B or the V column. We do have room for a red filter and an infrared if we decide to add those to our system. Each image has an error and an air mass. And what it looks for with this local date and local time is it's just looking for the beginning and the end of the session. And that way it can determine how many sessions we have, etc. So if we end up with a Julian date that has two Julian dates next to each other where the difference is about half a day, we know that we've started another session, as opposed to maybe a few minutes or even a few hours. It'll still think it's the same session. So that's kind of what's in here. I'm going to scroll down a little bit farther because we do have one more column here, this marks column. And what the program does in the analysis is it looks for high and low points. So here it found a high point with the B filter at 10.92 and the V filter at 10.72. What the analysis does, what the program does, is for each point that it's looking at, it looks to see whether it's the highest or lowest point compared to the other points in the same filter around it. So this 10.72 is higher than the magnitudes that came before it, and it's also higher than the magnitudes that come after it. So the program interprets that as being a high point or a peak. We have peaks and troughs, and so a high point, a peak there. If we scroll down a little bit further, you'll see that it has found low points. So we have a low point here in the V of 10.545. It's the same thing. It looks before and after, and it is determined that this 10.545 is the lowest in the general area. And same thing with this B filter over here, B filter magnitude of 10.688. So it marks these as high and low, and anything that is in this marked as high and low in this marks column will be added to the chart. So that's why we have these numbers in different places on the chart. It looks for those marks and puts those numbers on. So that first reading that we had, 10.72 for the visual filter and 10.92 for blue, is here. And then that's high, which means dim, and then low magnitudes, high, dim, high, low, high, low, high, low, until the end. Sometimes it doesn't put it at the beginning because it doesn't have enough data before the beginning or after the end to put a peak up there. It depends on how we have it set up in settings. So again, that's kind of how we can take a look at the data. If you want to make it a little prettier, there's a button here, a little program that says graph lines off or on. And we can click that. It can put the lines on. Click it again, it'll take them off. We do have, and it's kind of obvious in both ways, we kind of have this flat line in here where there's no data. And if we take the lines off, you'll see that we're missing data there. That is where the scope, since we have a German equatorial mount, where the scope flipped from east to west. And so we have it set up to focus again when it gets on the other side of the meridian. And it also has to do a plate solve and find our target star again. So this can take a little bit of time. And so that's why we usually end up having a gap in the middle. So that's kind of how this works. I'm going to go down here, scroll back down here again, and let's say that I just want to look at the B magnitudes for just one of the sessions. So all I have to do is click on whatever filter we have data for and double click on the B there, and I'll say there are 3 sessions. Default is to return all 3 sessions, or you can input the session number. Let's look at session 2, and this will return just session 2 for the B filter. And we are done. And one of the first things that you'll notice is there's no green dots on here because we did not ask for the V filter data. We just asked for the B filter data. And we've got the same sort of thing. We've got this nice cycle here in our second session. The chart reflects what we asked for, and Lin magnitude, session 2, B filter, and gives you the JD time and the local date and time. So this was the next night, the 15th into the 16th. The summary section over on the right will also indicate what we asked for. So the heading is summary session 2, gives us the time, gives us the number of sessions. And so originally we had 177 data points that we had in session 2, and it found 3 outliers. So it only used 174. That's still pretty good. And still binned at each image represents one data point on the graph. We don't have any V summary here because we didn't ask for any V. We only wanted B. So we've got 87 points in B, and you can see the different statistics for the magnitude and everything. If we scroll down here to the main section where all the data is, you'll notice that we only have B filter measurements. We don't have any V filter measurements because that's what we asked for. Okay, we come back up here. Again, you can turn the graph lines on or off if you want to. We still have that gap in there, obviously, because even though it was the next night, we still have a gap where the scope flips over. Okay, if we want to go back and see everything again, we have rotate sessions. We'll start with the first session and we'll go through each session in sequence, asking you if you want to stop on a particular sequence. If we want to go back and see everything, just double click this analysis button here and it will bring everything back up. You can do graph lines on and off here, but the way Excel works is it's going to draw a line between each of the sessions. So we've got these long gaps. This is called daylight hour. And so we don't really, this doesn't really help us all that much to have that on there. But these are all 3 sessions. And again, the summary will reflect that. And we'll say that in the chart. We'll also give us the JD again and local date and time. And in the summary, we can see that the total time was about 2 days and 6 hours, 45 minutes that we used for this imaging, 3 sessions. It did find 4 outliers from the standard deviation and the comp stars. So we started out with 504 data points. We ended up using 500. And we have all the different summary for magnitude and error, etc. And if we look down here, we'll continue down. The first session, we've got our first starting date and starting time. If we come down further, we'll see we've got the end. That's this first date line here, date and time. And then the second session starts here. So the first session ended January 15th at about 6:30 in the morning, as we said earlier. And our second session started on the same date, January 15th, but about 9:46 at night. And if we continue down, we do have a third session. And so this first line here is the end of the second session, and then we have the start of the third session there. So that's what we have. So that's for magnitude. We're going to go over and take a look at temperature. And so temperature, we don't use green or blue, we can just use black. So what the way that the temperature is determined is it groups the images together in 3s. That's how we ask the students to take their images, alternating between V and B with 3 each. So if we go back to our AIJ sheet, you can see that the third column is filter. We have 3 Vs, 3 Bs, 3 Vs, 3 Bs, 3 Vs, etc. And that alternates back and forth. I should tell you that in the AIJ sheet, if we do see outliers, in this first column under sequence, they're going to be marked with an X. So if we scroll down here, we do know that we had 4 that were, there's 3 right there that have been X'd out. There's something going on with the either the standard deviation or something else that's making the program think that we shouldn't use those. Okay, so we go to temperature. It's the same sort of thing. We've got a summary that gives us the time, how many sessions, the points, and then gives us the average, the temperature readings, kind of some statistics for Kelvin, and also since we're in Santa Rosa, California, and lay people like to use Fahrenheit, we use Fahrenheit. So don't get after me for that, everyone else. We do have Kelvin listed first. Okay, so we're going to scroll down a bit further, and this looks a little different than the magnitude sheet. We have since we have the B and the V values, we can subtract one from the other, do some math on that, and that will give you the Kelvin, the surface temperature of the target of the star. And so that's what we use. We have the same sort of thing for local date and time, where it's putting in the beginning and end of each session, and same sort of thing for peaks and valleys, peaks and troughs, low and high for the temperature. And we can see that, we can't really see that all that well with 3 sessions, but we can recall a single session. So let's look at session 3. We're going to look at session 3 for temperature. And there it is. And it's kind of, it can be a bit funky just to look at the dots. So we're going to put in the graph lines just to kind of see what we have here. And we've got the peaks and troughs in Kelvin, 8,720 Kelvin down to a little over 8,000. A little bit later, it came down below 8,000. And so it's pretty regular for a Delta Scuti star, and about right in terms of the change in magnitude and the change in temperature. So that's how the temperature works. Unlike the magnitude, you don't select for a specific filter in order to get the temperature. You need to have data from both filters anyway. So we can't do a temperature and select just for the V filter or just for the B. So those options aren't there. I want to go on to the comps sheet, because the comps sheet is actually you don't necessarily use it, but it's good to check it out, especially if you're looking for things like outliers. We can select in the settings to actually not have any outliers. And where is that guy? Outliers up here. How you determine the outliers. No removal at all. Remove outliers within individual sessions, which is the preferred way, or look at all the sessions at once. I'd like to go back to the comp sheet and just clear up some details on this. So our comp sheet is going to have a graph, and it's also going to have a summary, and then down a little farther it's going to have the actual data that it used to make the summary and to make the graph. It looks like the points are kind of bouncing around, but if you look at the y-axis here, they're only going between just under 0.3 to just above 0.3. So this is pretty normal. And again, we have a gap in here. We did have in the settings sheet, we did ask the program to not use any outliers. And so we wouldn't expect to see a point way far off from this kind of middle section here. So this is pretty normal and all okay. The summary is going to give us the usual things with the time, the number of sessions, how many data points it used. And then we're using, this is set up in the settings sheet over here, different ways to select the comp and check stars, either as ensembles or with just a single comp and a single check, and using magnitude or standard deviation for a parameter. If we come back to the comp sheet, it will tell you what method you used here. Comp check method. Ensemble check is the star with the best standard deviation. And so here's the check star, which is 000 BML 912. And then the remaining stars are the ensemble, so that's this. And so these comp stars are listed, and we've got plenty of room for plenty of comp stars here. And so that's where the measurement is done. It takes the ensemble measurement and subtracts the check. And what we want to have is we want to have a pretty steady, almost flat line, which we kind of have in the graph here, of measurements here. We don't want anything kind of changing a lot. If you do have a star that changes a lot, the program will notify you that the standard deviation is higher than what it should be, and will ask you whether you want to use that star. Because maybe you're using a comp star and the comp star ends up varying in some way that is not useful to you. Maybe you've discovered a new variable star, who knows. So it does that. We want to make sure that this is all pretty much flatlined, which it pretty much is. Again, this is really spread out in the y-axis here. All right, and again, we can go through the different sessions. If I want to recall the second session, I can grab that one. We've got pretty much the same data that we had in the first session, etc. Or you can again have all of them at once, and again, they're all pretty much kind of within the same range. All right, if we go back to the magnitude, again, if we want, we ended up with just looking at the first session. I'll run that again. Here's the first session with, again, the visual in green and the blue filter in blue. And if we want to come back and look at all the analysis again, we don't have to download and analyze. We don't need to pull up that data. The data is already on the spreadsheet, so we just have to click analysis, and it will recall the data. If you need to do a different star than the one that's here, then you do have to you have to go to the folder, download and analyze it. It only keeps the data for one star in here, the photometric data. It does, again, keep the chart ID and the comparison stars information. It keeps that on the spreadsheet, but it doesn't keep the actual measurement data that you had. So again, we have the summary. We have all the summary for the V and the B, and we have all the data down below here. If we want to do an AAVSO report, which is here, you need to have an observer code. So you can go to the AAVSO website for that and get an observer code. It's pretty easy to do. And once you have that, then you can use this program to write an AAVSO report. And we'll just go through that real quickly. We'll double click on Create AAVSO Report. I've taken the students' names out here and just have my name. Normally it would have a list of names with the observer codes, and you would select one. Or if you want to enter a new name here, you can do that, and it will then prompt you after your name for your observer code. Click OK. The current observatory is SPARQ, or you can select from the following options, but since we're just SPARQ, we don't have any other options right now, so you can type in your observatory if you want to. And the observatory name we like to have under the notes. So if we look at the headings for, this is the AAVSO page, the headings are in row 6, and we come all the way over here to the end notes. It will put in SPARQ Observatory in the notes, which is something that we want. So we're going to, if you want to enter anything else on the notes, it'll add it to SPARQ Observatory, but we'll go ahead and click OK. And it is completed. It's written the entire report. You can export it. The default is to export it as a text file wherever you want to put it on your desktop or back in your folder for your target star, wherever. I'm not going to do that, so I'll just type in some letters here and click OK. And gives you a message that's been written but not exported or saved. And we can look at what we have here. So the format, it's all in one column here, kind of crammed together all in one column, but that's how a text file would be uploaded to AAVSO. All this stuff up here is normal. You can see that under observer code, it has my observer code here. And then we have under date, JD, delimiting mark, which is the semicolon. And then we have the different parameters: name, date, Julian date, magnitude error, filter, transmission, magnitude type, etc. CNAME, ComStar magnitude, check name, which is the K mag, air mass, group, which is not needed for us, chart, which we input initially when we first put it in data for the target star, and then the notes. So in this first line, this would be the first data point. And if we come back over here to magnitude, we'll see that as we go to the data here at the bottom, that it has put things together in groups of 3, which is what we asked. So this first measurement, the JD, is the average of the first JDs in our session, and then the average V magnitude, average error mass. And so that's how that works. And you can see that it actually, the points are thinned out here. We don't have the time resolution that we had before, but we have more accurate measurements in our AAVSO report. So we've got that, we've got the magnitude, we've got the error, the filter is V, then we come over here, we're using an ensemble. This is the ensemble magnitude that we got, and the check and its magnitude, etc., air mass, etc. So it's got all that. It would be saved in a text file, and you can just submit that to AAVSO. The thing that we want to look at with our AIJexcel spreadsheet is to create a periodogram. and send that to the NASA Exoplanet website and see if we can extract a cycle, a regular pattern of what this star might be doing. And we're going to click on this create periodogram file. What's going to happen is it's going to take all the Julian dates and relative photon flux measurements for just the V filter. We don't want to mix the V and the B. That would give us some odd readings for our periodogram. So we just want to use the same filter, the V filter, for everything. So we're going to go ahead and click that. We can save this as a text file. The suggested name it's saying here is the name of the star, periodogram. There are no spaces because the NASA periodogram tool doesn't allow names with spaces. We have to upload this file. Here we have the two columns. Column 1 has the JD. Column 2 has the relative photon flux for our target star. We'll go ahead and click OK. It's going to save the file wherever your original folder was for your data. Same thing with the AAVSO report. I should mention that it's going to save it where you originally brought up the AIJ measurements table. We're going to click OK. And we can go ahead and select the hyperlink here that takes us to the NASA periodogram tool. Here it is. And we have to choose the file and then we have to upload it. So we're going to choose the file. We're going to navigate to our ANLIN periodogram text file, which is here. So it does have to be a text file. We're going to select it. We're going to open it, and now the website has it, or is about to have it. We're going to upload it. Here we go, uploading it. It takes a few seconds. And it's telling us that down here that it found 249 points. It gives us the time range in Julian date and gives us the data range, the change in the relative photon flux. And we're now going to select calculate periodogram. This will take a few seconds. And what it'll do is it'll put a graph up showing the relative strengths of what it gets from the Fourier analysis. And what we're primarily interested in is if there's a single strong peak, which it looks like there is in the middle here. We've got a few other peaks that are fairly strong, but we've got this one peak here in the middle. And so that's going to be the first ranked peak in this table that's over here to the right, table of peaks. We're looking for the first rank, and it says 0.098, etc. That's the period. So the period of whatever this variable star is doing, this period is in days, so 0.098 works out to about, I'm going to say about 2 hours and 20 minutes, maybe a little over 2 hours and 20 minutes for the period. And we can check that and see if that's kind of what we have for some data. What we're going to do first is we're going to come over to the magnitude sheet, and we're going to use this last column way over here, this marks column. And when we originally do an analysis, when the program does an analysis, the marks column just puts in where the high and low peaks and valleys are. So for each filter, so here we have the first high for blue, which is 10,920, so that's dimmer part, and same thing with the V filter, 10,720. What I want to do is I'm just going to call up one session so I can kind of show you what you can do with that marks column. We're going to go ahead and let's call up session 2. Just pick one at random here. It's called up session 2, and we're going to look at as soon as I can find my cursor, we're going to look at maybe these first two peaks in V, so 10.551, 10.540. So what we're going to look for in the marks column is we're going to delete all these other marks that are assigning the magnitudes to the chart, except for those first two V's, the first two V's that are low. As a matter of fact, I can make this a little simpler. As I demonstrated before, we can select just a single filter. So let's just select the V filter, and we'll do the second session. And there we have it. And we're going to be looking for the first two low points here and see what kind of, I'll show you how we kind of get an idea of what the time frame is, the time scale is. So here's the first low. and that's fine. We're going to keep that. Here's a high. We're going to delete that guy out of the marks column. We're going to keep the next low, and then all the other ones we're going to just delete. So we only have those first two. And there's a reason for this. This is going to actually send those first 2 points. Any points you mark in here, in this marked column, can be sent to the Julian date sheet, Julian date conversion, JD conversion. And you do that by clicking marks to JD. And so we'll just go ahead and do that for those first two magnitudes. And it just sent those Julian dates here. And we have a period of about 2 hours, 22 minutes, and 13 seconds or so, which is what we came up with. That's 0.098 times the number of hours in a day, 24, and we get about, as I said, a little over 2 hours. So 2 hours and 22 minutes, that's about the cycle for this star. So that's the things that we can do with this spreadsheet. Primarily, again, we download the data from the AIG measurements tables, do an analysis, we get light curves from it. We can look at individual sessions as well as individual filters. We can, if we want to make things a little prettier, we can put lines on the graph. We can take the lines off the graph. The graph is marked as best as it can with the peaks and valleys of the light curve if it can determine such things in a good way. We can also create an AAVSO report. We can create a periodogram file, and then we also have a summary. And this is the summary for just the second session for the V filter, and it's got the number of points. It's got the information about the magnitude, the error, and of course the time for that second session. So that's it for our photometry projects. You can take screenshots of this, kind of slice and dice the data as you wish. And this was a good project to do. Look forward to seeing your finished projects when you get them done. Thanks for joining me, and I will see you out at the SPARQ Observatory.